this is getting at the size issue thing that was brought up earlier. So at the SCUP conference, all of these architects and so forth were asking me about, so yeah, you have 27 and 45 and 54, all these denominations of 9 kind of going up to 126. Which size classroom is the best? Or what are the differences? And I didn't have an answer for this, in large part because the preliminary analysis said there are no differences between them. But this got me thinking very seriously about the possibility of figuring out where the upper threshold might happen to be is. And so even while I'm sitting in one of the sessions at the conference, I begin noodling around with the data set to look at correlational patterns between things that might be related to size, and to see whether or not size might affect these theoretical constructs that we have in terms of engagement, flexibility, enrichment, and that kind of thing. So the initial pass on correlations wasn't that effective in terms of size. This is where we weren't getting much of anything. There might be one or two, but it wasn't a systematic pattern, didn't warrant sort of full-scale modeling. Then I was talking with one of my other colleagues, and he started getting me to think about other things in terms of perhaps the percentage of the classroom that's filled, using that as a control, and a whole slew of other things. And so just this last week, I started modeling this out. And so the dependent variables are on that 1 to 4 scale. It's a Likert scale, and the difference between 1 on that scale and 2 on that scale is not the same as the difference between 2 and 3 and 4, right? So the difference between strongly disagreeing and disagreeing is probably not the same as disagreeing versus agreeing, or agreeing versus strongly agreeing. So you have to use this special model called an ordered logistic regression model. So it's the same kind of model that you would have if you have a dichotomous variable, but it's treating all of those different categories as dichotomous relation, or treating all of those as logistic relations within there. And just right before I came, well, it was right at the end of last week, I actually hit the jackpot in terms of being able to model this. Again, using the post hoc Monte Carlo simulations, because we're dealing with relatively small numbers in terms of trying to make this work. And so classroom size becomes a constant even across a whole slew of these. So we use the Monte Carlo simulation to play it out. And there are no, we get strong responses for engagement across all of the sizes that we actually have. So the N of 27, 45, 54, 63, 90, and 126, those are real rooms that we have. But the great thing about the simulation that I run with the Monte Carlo is I can start plugging in other numbers, just like you would with a regression model, right? You have the real data, and then you can predict out linearly to infinity or negative infinity what that curve would fit. So I can keep on plugging in denominations of 9 because each table is 9, and actually pinpoint the point at which we begin to see those things cross. And I haven't pinpointed them yet for all of them, but it happens somewhere between 126 and 252, which is a doubling of that room. So somewhere between there is a point at which student engagement drops below the 50% threshold. In other words, where the active learning classroom disengages you more than it engages you. And we might even want to consider putting a higher threshold to that, looking at how well, what does all of the data that we have about traditional classrooms, if we aggregated that up, what is the average level of engagement in a traditional classroom? And let that be the marker, not the 50%, not the point at where it crosses out there way out there, but use the traditional one. Because if the active learning classroom doesn't engage you any more than the traditional classroom, why build it? And I'm anything if I'm a skeptic, right? If educational technologies of these spaces isn't working and isn't showing an improvement, what good are they? And I mean that in every sense of the word. As a scientist, I don't want to see us throw money at some sort of educational initiative that's not going to have an impact. So maybe that becomes the threshold. And so as more and more people are saying, well, what size, how big can we go with this? We might be able to actually tell, especially given the size of the data that we have here, we might be able to actually tell classroom managers, college and university planners, architects, don't build rooms larger than X, because the law of diminishing returns kick in and you're not getting any bang for your buck in doing so. And the practical implications of that This is one reason why I don't miss political science and I like this, is because the practical implications of what I do are far more meaningful. They're tangible in very meaningful ways. And because this is new data, I couldn't resist putting two of the graphs in. So this is the enrichment one. But they both look pretty similar.